Hello everyone, I am Professor Amit Thakur. In this session, we are going to cover the fundamentals of language C. We are going to cover topics like data types, array. In later session, we will see the different operations in array also, the pointers, structures, union and difference between structure and union also. At the last of this session, we will discuss about various dynamic memory allocation and also we will see what are the advantages of dynamic memory allocation and in C. By the end of this session, you will able to discuss about importance of data types available in C, explain the importance of array and pointers in C, what are the differences between array and pointers, we will also see this topic, discuss the structure and union in C and what are the differences between structure and union in C, explain how to use dynamic memory allocations in C. First, we will start with various data types available in C and also we will discuss various types of data types. C data types provide flexibility and control over how data is stored and manipulated in a program, which is essential and for efficient memory usage and accurate data representations. Understanding data types is a crucial for writing robust and efficient program. In language C, data types are used to define the type of data that a variable can hold. The C language provides a variety of built-in data types that allow programmers to work with different types of data efficiently. Data types which are available in C. In C, every variable is linked to a specific data type indicating the kind of data it can hold, such as integer, character, float and double and different kinds of data types. Each data type require varying amount of memory and comes with distinct operations that can be performed on it. A data type represents a collection of data with predefined values and characteristics. These are the data type we can classify into three categories. The first is primitive data type, also known as a predefined, user defined data type, that is non-primitive, and last one is a derived data type. When we talk about primitive data type can be are the most basic data type available in C, and a simple format we can have like data types like characters, integer, float and double. User defined data type, the user defined data type are the defined by the user himself, and last one is the derived data type that are derived from the primitive, or we can say is a predefined data type, and those comes in the derived data type. In C, data types are way to categorize and specify the types of data that a variable or expression can hold or represent. They define the size, format and the range of values that a particular variables can store. A C programming language provides several built-in data types, each designed to handle different types of data efficiently. By using appropriate data types, we can ensure your program works correctly and efficiently with minimal memory usage and the ability to handle various types of data in a structured and organized manner. Different data types also have different ranges up to which they can store numbers. These ranges may vary from compiler to compiler. We have different kind of like 32 bits, 64 bits. So, we can have different kind of compilers and according them we can store the data. Below is a list of range along with the memory requirements and the format specifier on a 32 bit GCC compiler. These are the categorization of data types in C. As I told you earlier, the primitive or primary data types and those like integers, characters, double, floating point, those comes under the primary data type or primitive data type. Under the derived data type, we have function, array, pointers and references, and the last is user defined data type, the class, structure, union, enum and type def. Sometimes this class does not consider and in language C, so we can omit in language C. In C, the format specifiers are special placeholders within formatted input and output functions to define the type and the format of data being read from or within the standard input output streams or files. These format specifier act as a guide for the compiler to correctly interpret and process the data during the input output operations. They are they are essential part of C formatted input output functions like printf, scanf, fprintf and fscanf. It is important to use correct format specifier to match the data type of corresponding variables. Failures to do so lead to undefined, or we can say a different behavior or incorrect results. This table is all about the data types, their size in bytes, range they may vary, at the last this format specifiers. We can see we have 4 columns over here. The first column like data types, second is the size in bytes, the third column this range, and the fourth column is format specifier. The first we can talk about sort integer. The size of sort integer is 2 bytes, and you can see the range and from negative to positive, and the last is the format specifier, that is %hd. And the second is unsigned sort int. The size is 2 bytes. We can see the range. These are the positive numbers, that is from 0 to 65,535, and the format specifier is %hd. Likewise, we have categorized different data types in this this table. Again, you can see different data types, and we have like signed characters. The size is 1 byte, and we can see the range, and the format specifier is %c. And apart from this character, we have listed some different data types, and you can see this from this table. In summary, C provides a variety of data types to accommodate different types of data and their specific requirements. Understanding this data type is crucial for correctly representing and manipulating data in C programming. This is the next is minimum and the maximum limit of various data types. The limits.h header file is responsible in C to decide the size of these data types available in C. As we can see, we have each and every data type having minimum and maximum limits of various data types. The limits.h header file in C is a part of C standard library and defines constant that specify the minimum and the maximum limits of various data types available in C. The constants defined in limits.h header file implementation is specific and depend upon the architecture of the compiler and operating system being used. Some of the common constants defined in limits.h header file, those are int underscore mean, those are on all capital. The minimum value that can be represented by integer data type, this is a constant. Like int underscore max, it is also a constant, it defines the maximum value that can be represented by integer data type. uint underscore max, this is the maximum value that can be represented by unsigned data type. The character, we can talk about the character limits. The character underscore mean, char mean, this is the minimum value that can be represented by the character data type. Char underscore max, the maximum value that can be represented by a character data type. As char mean, this is signed data type, character data type, this is a minimum value that can be held, and as char max, this is the maximum value that can be represented by signed character value. Unsigned character max, this is the maximum value that can be represented by unsigned character data type. Sort integer, now we can talk about the sort integer. srt underscore mean, this is the minimum value that can be represented by sort data type. shrt underscore mean, max, the maximum value that can be represented by the sort data type. shrt underscore max, this is the maximum value that can be represented by unsigned sort data type. Likewise, now we can talk about long integer limits. Long underscore mean, this is the constant which is used to check the minimum value that can be represented by long data type. Long underscore max, it is also a constant that is used to define the maximum value that can be represented by long data type. long underscore max, this is a constant, this is represent to maximum value that can be represented by unsigned long data type. This constant provide important information about the range and the representation of various data types, allowing programmers to write portable code that works across different platforms and compilers. When work with integer character data type in C, the limits.h header file is valuable resource to ensure your code is using the correct data type and avoid overflow and unexpected behavior. Now, we will talk about the array. In C, the array is a collection of elements of same type that are stored contiguous memory location. Array provides a way to store multiple values of the same type under the single variable name, making it easier to work with the large set of data. Each element in array is accessed using an index which represent their position of the element within the array. Array have several unique characteristics that make them a better and powerful data structure in programming. The first point we will discuss about the contiguous memory. Array stores element is in contiguous memory location, which means the elements are stored one after another in memory. This property allows for the efficient access to individual elements using their indices, since the memory addresses of their first element can be used to calculate the addresses of the subsequent element. The second characteristic is constant time access. The access element, this accessing the element in the array is a constant time operation, that is it takes the same amount of time for accessing the rest of the element. The next is indexed access. Once we have the index of element, we can simply put the index number and we can access the element present in the array. Homogeneous elements. Array can only hold elements of the same data type. The homogeneity ensures the memory layout is predictable and that the size of the each element is consistent. The point is size determines the compile time. In most cases, the size of array in C is determined at the compile time and can be changed during the runtime. This characteristics means that the size of array is fixed and can be changed dynamically or resized without creating a new array. The next point is memory efficiency. Array are memory efficient as they allocate contiguous blocks of memory of their element. This reduces the memory overhead and makes array suitable for large data sets. The next point is efficiency for the iteration. Array are excellent for iterative processing such as looping over elements to perform a specific operations, since elements are layout on subsequently literally iterating through array is straightforward and efficient. In C, array is a collection of elements of same data type that are stored at contiguous memory location. Array provides a way to store multiple values at the same time under the same data type name, making it easier to work with the large data sets. Each element in array is accessed using the indices with representation of their position of their element within the array. This is a simple example. An array is a collection of elements, as I told you earlier in previous slides. This is the simple example where we can have multiple elements we can store in the array. We have a list of 1000 students, marks of integer type. So, we can simply use we cannot have different data type, we can different variables like int from marks 1, marks 2 up to marks 1000. Simply in place of this we can have array of thousands element. Now, you can see this is the slide where you can see that number of variables are declared, but this is not a suitable programming paradigm. So, we can have array in place of this various variables. By using this syntax int student marks in bracket 1000, this is subscript defines the size of this array. This will reserve 1000 contiguous memory location for storing the students marks. Graphically, this can be depicted as in the following figure. Now, you can see this is the diagram of array, how the value are stored in the array. As you can see, we have different indices starting from 0 to up to 999, and these are the ranges of data. How can you store this data into the array? The array always starts from 0, and the first address of array is known as the base address of this array. Dimension refers to array size, which is how the big array is. A single or one dimensional array declaration has the following format or following syntax: data type, after that we can provide the array name, in the bracket we can provide the array size. Here data type defines the base type of the array, which is the type of each element in the array. Here array name is the valid C identifier that name that obeys the rules under the identifier, and the last is array size defines how many elements that array can hold. To address some of the limitation of array, higher levels data structures like linked list, dynamic array or resizable arrays are used in more complex applications. Nevertheless, array remains a crucial building block in programming and are widely used due to their simplicity and efficiency of their certain tasks. Now, we will talk about array initialization. An array may be initialized at the time of declaration. It is used for giving initial values to the array. Initialization of array may take the following forms: type, array name, the size. After this we can have opening and closing curly braces. Within this opening and closing curly braces we can provide the list of values. For example, the first example is number, integer id number, and we have taken 7 is the size of array and we have initialized from value 1, 2, 3, 4 up to 7. The second is a float. We have taken variable name f float num and the size is 5. Now, we have listed different float values under this array. The third is character and this variable name is character vowel. We have taken size of array 6. Under this we have initialized values from a, e, I, o, u, and the last is null character. We can make sure, suppose we have taken character as we have initializing character. So, we have to use single quote to initialize the character for the array. The first line declares integer array starting from 0 to and up 0 from starting from 0 and so on. The second line assigns the values from 5.6 to and so on. Similarly, the third line assigns the character from a to e, and the last will be denoted by the null character. The types of array, we have different types of array. We have listed some arrays type. In C, there are several types of array based on their properties, use and usage. Some of the common types of array are 1D array, that is one dimensional array, 2D array, two dimensional array, and the last is multidimensional array. Each type of array serves different purposes, and choosing the appropriate type depends upon the specific requirements of the program. Understanding the characteristics and use case of different array type is essential for efficient and effective array manipulation in C program. First, we will talk about this 2D array. If we assign initial string value for 2D array, it will look like something like we have character, name, and we have provided two sizes like 6 and 10. The 6 is a number of rows and 10 is a number of columns. As you can see, we have initialized 6 name for the 2D array. Here we can initialize the array with 6 strings, each with a maximum of 9 characters long. It depicts in row and column, it will look like something following that can be considered as a contiguous arrangement in the memory. Now, we will discuss about pointers. In C, a pointer is a variable that stores the memory address of another pointer or another variable. Instead of directly holding the value, a pointer points to the memory location where the value is stored. Pointers are used to manipulate the memory, access the data directly, and create more efficient data structures like linked list, trees, and dynamic arrays. Be cautious when using pointers. Improper uses can lead undefined behavior of memory related bugs like segmentation faults. It is crucial to ensure that the pointer is valid and points to a valid memory location before performing any operations with it. When declaring a variable, the compiler sets aside memory storage with a unique address to store that variable. The compiler associates that addresses with the variable name. When the program uses the variable name, it automatically accesses a proper memory location. no need to concern with the addresses, but we can manipulate the memory addresses by using pointers. Let us declare a variable name like rate of type integer and assign that with value of 10. Here we can see int is a data type, rate is a variable name, and we have assigned value of 10. You can see this code from starting void main. Under this void main, under function, we have used a variable rate equals to 10. Now we are trying to print the value of the variable name is rate, and we are trying to print the value. The first is the size of array, that is the size of rate is integer. Sir, isko फिर से बोलो. We can see there is a main function. Under this we have one variable integer, rate equals to 10. We have taken rate as a variable name and type of is integer, and we have taken value of 10. The first line printf variable name is rate, we are simply printing a message here. The second line, the size of array, bracket we have used int is %d bytes. This is, here is size of function is used to print the size of this integer variable, this is of 2 bytes. Suppose we have at the last we are trying to print initial value at rate, and we have using %d, and simply we have put rate variable. So this statement will print the value of rate. At the last we have used memory address of the rate is %u. %u is used for unsigned integers, and we have used %sign with the rate. This will print the address location of this variable stored. Here we have used 65,522 we have just this printed the memory of this rate variable. So the pointer variable declaration becomes something like this integer. Here we have used variable p to rate with the pointer with asterisk sign. In other word, the p to rate variable holds the memory address of rate and is therefore a pointer to rate. The asterisk sign used to show that is it is a pointer variable instead of normal variable. Now we can define this pointer like a pointer is a variable that can hold memory address of another variable where the actual data is stored. In C, a pointer is a variable that stores the memory address of another variable. Pointer provides a way to indirectly access and manipulate data by pointing to the memory location where the actual data is stored. A pointer is a numeric variable and like other variable must be declared and initialized before it can be used. The following is a general form of declaring pointer variable like type of stored data. Here is the first is type of stored data. After that we have to use this asterisk sign, and after asterisk sign we can provide the pointer variable name. After pointer variable name we have to use this semicolon. For example, character pointer, and we are providing the variable name character pointer name. Here character ch name is a pointer which can hold the address of any character value. The next line, the type of stored data is any valid pointer base type such as character, integer, float or other valid C derived data type such as array and struct. It indicates the type of variables data to which the pointer is pointing to. The pointer variable name follows the same rules as C variables this naming convention and must be unique. Pointers are powerful tool, but they require a careful handling to avoid memory related bugs like segmentation, faults and undefined behavior. Understanding pointers is essential for advanced C programming and memory management. Once a pointer is declared, we must initialize it. This makes the pointer pointing to something. Do not make it pointing to nothing, it is a dangerous. Uninitialized pointer will not cause a compile error, but using a uninitialized pointer could result in unpredictable and potential this disastrous outcome. Until pointer holds an address of variable, it is not useful. C uses two pointer operation. The first is indirection operator like asterisk sign. Asterisk symbol has explained previously already. The second is address of operator, that is ampersand sign. This ampersand symbol means returns the address of. When ampersand sign is placed before the name of any variable, it will returns the memory address of that variable instead of stored value. Some facts about the pointer. One interesting fact about pointer in C that they allow you to directly manipulate and access memory addresses, giving you fine-grained control over memory management. This capability makes pointer to powerful tool in programming and enables various advanced features. Second is powerful data structure. Also see this pointer is a very powerful structure, data structure in C. Pointers are basically building blocks for many this advanced data structure in C, such as linked list, trees, graph, dynamic arrays. These data structure are essential for solving this complex problem efficiently. Pointers allow elements of this data structure to be dynamically allocated and linked together, enabling dynamic resizing and efficient memory usage. For example, consider linked list, where each node points to the next node in the linked list using pointers. The linked list can grow or shrink depending upon this runtime and requirement, and each node can be allocated separately, facilitating more flexible and efficient memory management. Pointers are used to implement complex algorithms and algorithms that involve efficient memory manipulation, like those used in low level system programming and embedded system. While pointers provide powerful capabilities, they also require careful handling to avoid common pitfalls such as dereferencing or uninitialized or invalid pointers, causing memory leaks or something like segmentation faults. Hence, mastering pointers uses is crucial to writing this efficient code. Difference between array and pointers. Array and pointers are closely related concepts in C, but they have distinct characteristics and uses. Here main characteristics between main differences between this pointer and array are: the first is data structure. Array is a collection of elements of same data type stored in the contiguous memory location. The elements in array are stored by using their indices. In pointers, a pointer is a variable that stores the memory addresses of another variable. It points to the memory locations of data item. Second is memory allocation. Array memory location is allocated at compile time, but in case of this pointer memory allocated at the runtime. Next point is accessing element. By array we have different indices by which we can access the array element, but in case of pointers we have two operators like asterisk sign and ampersand sign. For asterisk sign, this asterisk sign is used to access the data from the pointer. The next is pointer arithmetic. Now, array will have suppose different pointer arithmetic. For example, you can increment an array pointer to move to the next element of the into the array. In pointers, we can perform pointers arithmetic to navigate through memory, but it isn't directly related to the array. The next difference between array and pointer is array decay. When we talk about array, when passed to a function as an argument, an array decays into a pointers to its first element. As a result, the size of array is lost and the function cannot determine the array's original length. When we talk about pointer, a pointer retains its value and can be passed to the function without losing the memory addresses information. Now we talk about structure. Important topic of this structure is, in C, structure is a user defined data type that allows you to group multiple and variables of different data types under a single name. A structure enables you to create a custom data type, often referred to as a composite data type, that can represent a more complex and meaningful entity. Structures are useful for organizing related data into a single entity, making the code more readable and maintainable. They are commonly used in scenarios where you need to represent complex objects, records or entities in a program. Structures can also be nested within the structure and known as a nested structure. Additionally, you can use pointers to structure to efficiently manipulate large structures or pass structures to functions by references. C provides a shorthand notation or defining a structure and creating variables simultaneously called type def. This allows you to define structure and declare a variable of that structuring using a single line. Structure is a convenient way of grouping several pieces of related information together. It is a collection of variables under the single names. The variables in structure can be of different types and each has the name which is used to select it from the structure. For example, we have ID of type of integer and name of type of character array. Now, we can put this data types together into a single structure. The definition of structure, like a structure is a new name type that may involve several different typed variables. This is the composite or compound data. Inside structure we have student record like integer roll number, character name, character array name, and last is float marks. So, we can put these three members into a structure. Like we have this example is we have created one struct student. Struct is a keyword to define a structure. Under this structure we have three members like roll number, name and marks of different types. To access this members, we can have a new structure type of data, that is st1. Here st1 is a type of struct student. To access the members, we have to use dot operator like st1 dot roll number, st1 dot name and st1 dot marks. So, dot operator is used to access the members of this structure. Now, we will see union in C. In C, a union is a user defined data type that allows you to store different data types in the same memory location, unlike a structure which allocates memory for each members separately. But in case of union, that shares a same memory space for all its members. As a result, union can only store one member's value at a time. The size of union is determine the largest member. In C, union is a unique data type that enables the storage of various data types in the same memory location. While you can define a union with multiple members, the only one members can hold a value at given time. This features allows union to efficiently utilize the same memory location for the multiple purpose. This is the simple syntax to define or to declare a union. Here union is a keyword. After union keyword, we need to provide the name of union, opening curly braces and the closing curly braces. Under this, we need to provide the members of union which we want to put inside the union. Unions are commonly used in situation where you need to represent different types of data that share the same memory space, or when you want to save memory by ensuring that only one members is used at given time. It is essential to use unions with caution, as accessing the wrong members can lead to the incorrect data and this potential bugs. Unions are most suitable when you know which type of data will be stored and need to conserve memory to reusing the same memory space for the different data types. As we have seen this, this is a syntax, simple syntax of union. We have union keyword, after that we have this union name, and inside this we have members of the union. Note, the memory occupied by the union will large enough to hold the largest member of the union. For example, in the above example, the data type will occupy 20 bytes of memory space, because this is the maximum space which can be occupied by the character string. So, here I conclude my this session. Remember, learning is a continuous journey, and I encourage each of you to keep exploring and seeking knowledge beyond this session. So, thank you so much. Thank you.